strands of beta structure interact with helices. That's the realm of tertiary structure. And people first discovered this in fibrous proteins, so we'll take a look at a couple of those. Fibrous proteins, or like hair proteins, things like that, they're proteins, just very, very long fibers. Different from the kinds of proteins inside the cell, but they're useful because they're just repetitive versions of like secondary structure. They tend to play a structural role. They tend to be strong proteins, not water soluble. So alpha keratin, which is built from the alpha helix, it's a hair protein. Silk, as we've said, is built from beta strands. And collagen, which has its own unique secondary structure we haven't talked about yet. We'll only have time to look at two of them. We'll look at the hair protein, the alpha keratin protein, and we'll look at collagen to see examples of tertiary structures. So here is alpha keratin. It basically, it's got some head roots, but it's basically long stretches of alpha helix, and it's built into a rope-like structure from like 16 of these. So you'll have a basic alpha helix, and two of those come together and twist around each other to make a so-called coiled coil. If you take a pair of those, you get a protofilament, and four of those protofilaments wrapped around each other make this huge cable that's typical of the structures inside hair. And in addition, so it's held together by the hydrogen bonding, the end-to-end plus 4 pattern that's in here. But also, as you wrap these helices around each other, you get disulfide bonds forming between one coil and the next. And that's what makes some alpha helical, alpha keratin proteins stronger than others. So this is the protein in hair. It's kind of flexible. It's also what builds fingernails. Fingernails have alpha keratin protein in them too. It's a little stronger than the hair protein because it's got more disulfides. Horns on animals, like the horns on a cow, really tough, right? They're made out of the same alpha keratin protein, but they have more disulfide links.
What about skin? Does it have keratin?